In this video, I will talk about oblique asymptote, sometimes called the slant asymptote. Now, what's an oblique asymptote? Let's say you have a function f at x equals to a function in the numerator divided by a function in the denominator. So let's say you have ax to the power of n plus other terms in the numerator divided by bx to the power of m plus other terms in the denominator. Let's say like that. If the highest degree of power in the numerator is exactly 1 greater than the highest degree of power in the denominator, then there should be an oblique asymptote in this function. So in other words, let's say n is the highest degree of power in the numerator here, and m is the highest degree of power in the denominator here. If n is exactly 1 greater than m, then there should be an oblique asymptote. And how do you find the oblique asymptote in the function? You have to use a long division. So let's do that. Here, let's say you have ax to the power of n, which is the numerator, divided by bx to the power of m plus other terms, which is the denominator, right here. So whatever you get here will be your oblique asymptote, regardless whether there's remainder or not in this division. Okay, now let's look at it from the calculus perspective. Now, let me draw a Cartesian plane here. It has the y-axis, right? It has the x-axis. Let's say there's a function like this, and that's the function y equals to f at x, like that. And there's an oblique asymptote here. Let's say like this. And the oblique asymptote takes form of a straight line. And we can model this by y equals to mx plus b, because it's a straight line, right? Okay, now let's look at the vertical distance between y equals f at x and the oblique asymptote. Let's say from this point on the function f at x down to this point on the oblique asymptote. Here, let's say here has a vertical distance, right? And then as you go to the positive x direction, the vertical distance is getting smaller and smaller, right? So the function f at x, or we should say that the oblique asymptote is getting closer and closer to the function f at x, right? As you can see, right here, as it goes to the positive x direction, the vertical distance between the function f at x and the oblique asymptote is getting smaller and smaller. As it goes to the positive infinity in the x direction, the distance between the f at x and the oblique asymptote should be getting to 0. That's what an asymptote means. So we can write it like here, like this. Limit as x approach positive infinity, f at x, right, minus, right, this function models the oblique asymptote, right, should be equal to 0, right? The distance between f at x and the oblique asymptote should be getting to 0 as x approaches infinity. Like here, going this way. Okay, now let's do some examples and see how this works. Now, example number 1. Let's say you have a function f at x equals to x squared plus 1 divided by x minus 1. Now, the highest degree of power in the numerator is exactly 1 greater than the highest degree of power in the denominator, then we should have an oblique asymptote. How do we find the oblique asymptote? We'll use a long division. Okay, so let's do this. X squared plus 1 divided by x minus 1. Okay, so here we will put x, right? X times x is x squared. Negative 1 times x is negative x. Okay, so here x squared minus x squared is 0. 1 minus minus x will become x plus 1. Okay, we can still divide. So in this case, plus 1, right? X times 1 is x. Minus 1 times 1 is minus 1. In this case, x minus x is 0. 1 minus minus 1 is 2, right? Because it's 1 plus 1. Okay, can you still divide further? No, you cannot. So that's it. It doesn't matter whether that's remainder or not. The oblique asymptote is this equation here, right? X plus 1. So the oblique asymptote is y equals to x plus 1. Now, let's put into the limit here and see if we get to 0. Okay, so limit as x approach infinity, f at x minus mx plus b equals to limit as x approach infinity. It's this one here, right? X squared plus 1 divided by x minus 1 minus mx plus b, which is this one, x plus 1. Now, what do we do next? Find the common denominator so we can group this term together. So I have to multiply this one by x minus 1 divided by x minus 1. So let's do it here. X plus 1 times x minus 1 divided by x minus 1, right? The top here will become x squared minus 1 now divided by x minus 1. Okay, so that's equal to limit as x approach infinity, x squared plus 1 divided by x minus 1 minus this, x squared minus 1 divided by x minus 1. Now, group this together. We have x squared plus 1 minus x squared minus minus is plus, right? Plus 1. Divided by x minus 1. Now, over here, x squared cancel out. All I have left is just 1 plus 1, which is 2 in the numerator. So that is 2 divided by x minus 1. Now, you can put infinity into x here. Now, once you do that, you have 2 over infinity minus 1. Now, infinity minus 1 is a very, very large number. So you have 2 divided by a very, very large number, which is close to 0. Okay, so this is equal to 0, which means this works. Let's do another example. Here, example number 2. Let's say you have a function f at x equals to x cubed plus x squared plus x divided by x squared plus x. Now, in this example here, the highest degree of power in the numerator is exactly 1 greater than the highest degree of power in the denominator. Then you should have an oblique asymptote. How do we find the oblique asymptote? Let's do the long division again. X cubed plus x squared plus x divided by x squared plus x. Now, I should put x here, right? X times x squared is x cubed. X times x is x squared. Now, x cubed minus x cubed is 0. X squared minus x squared is 0. X minus 0 is x. Can you still divide x squared plus x into x? No, you cannot. So that's it. You have to stop here. So this is the oblique asymptote. Y equals to x. Again, let's put into the limit and see what we get. Limit as x approach infinity, right? F at x minus mx plus b. That's equal to limit as x approach infinity. What's f at x here? This, right? So it is x cubed plus x squared plus x divided by x squared plus x minus, this is just x, so minus x. Okay, so we have to find the common denominator to group this term together. So let's do it here. So I have x times x squared plus x divided by x squared plus x. And that gives me x times x squared is x cubed plus x times x is x squared divided by x squared plus x. Okay, now that's equal to limit as x approach infinity, x cubed plus x squared plus x divided by x squared plus x minus this, x cubed plus x squared divided by x squared plus x. Now group this together. We have limit as x approach infinity, x cubed plus x squared plus x minus x cubed. Now minus plus will become minus x squared. Divide by here, x squared plus x. Over here, x cubed and x cubed cancel out, x squared and x squared cancel out, all I have left is just x in the numerator. So it's x divided by x squared plus x. Now, you cannot really plug infinity with x yet, because we have infinity over infinity squared plus infinity. That doesn't give you the answer, right? What we can do is divide the top and bottom by x. Like that. And I have not changed anything. So now, what do I have? Limit as x approach infinity, I have x over x is 1, divided by x squared over x is x, plus x over x is 1. Now, you can put infinity into x here. Then you have 1 divided by infinity plus 1. Infinity plus 1 is a very, very large number. So 1 divided by a very, very large number is close to 0. Okay, so this is equal to 0 again, so that works, right? Let's do another example. Let's say example number 3. Say f at x, right, is equal to 4x to the 4 plus 2x cubed minus x squared. All divided by 2x cubed minus x squared. Now, the highest degree of power in the numerator is exactly 1 greater than the highest degree of power in the denominator. Then that should be an oblique asymptote. How do we find the oblique asymptote? We do the long division again. So 4x to the 4 plus 2x cubed minus x squared. All divided by, right, 2x cubed minus x squared. Now what do? Here, what's this term here? It should be 2x. Because 2x cubed times 2x is 4x to the 4, right? Minus x squared times 2x is minus 2x cubed. Here, 4x to the 4 minus 4x to the 4 is 0. 2x cubed minus negative 2x cubed is 4x cubed minus x squared. Okay, now, what's next? Okay, so I should plus 2, right? 2x cubed times 2 is 4x cubed minus x squared plus 2 is minus x squared times 2 is minus 2x squared. Now 4x cubed minus 4x cubed is 0. Negative x squared minus 2x squared is positive x squared. Now can we divide 2x cubed minus x squared into x squared anymore? No, you cannot. So that's it. So this is the oblique asymptote. Y equals to 2x plus 2. Now again, let's put into the limit and see what we get. Limit as x approach infinity, right? F at x minus mx plus b. And that's equal to limit as x approach infinity. What's f at x here? This, right? So 4x cubed plus 2x, 4x to the 4 plus 2x cubed minus x squared divided by 2x cubed minus x squared. Let's see. Yeah. Now minus here, 2x plus 2. Okay. Now, of course, we have to find the common denominator and then group this term together. Okay. Now, here, 2x plus 2 multiply by 2x cubed minus x squared divide by 2x cubed minus x squared, right? So that I'm not changing anything. So now the numerator becomes, now that would be 4x to the 4 minus 2x cubed, now plus 4x cubed minus 2x squared. Okay, so the middle part here is just plus 2x cubed, right? Okay, I can write that here. Plus 2x cubed divided by here 2x cubed minus x squared. Okay, so this is this here now. Equals to limit as x approach infinity 4x to the 4 plus 2x cubed minus x squared divided by 2x cubed minus x squared minus this one 4x cubed or 4x to the 4th right here plus 2x cubed minus 2x squared divided by 2x cubed minus x squared, like that. Now group this together. 4x to the 4 plus 2x cubed minus x squared minus 4x to the 4. Now minus plus become minus. Now minus minus become plus. All divided by 2x cubed minus x squared. Now 4x to the 4 and 4x to the 4 cancel out. 2x cubed and 2x cubed cancel out. Now minus x squared plus 2x squared will be x squared left in the numerator. So limit x approach infinity x squared over 2x cubed minus x squared. Okay, now you cannot directly plug infinity into x here, right? What we should do is divide the top and bottom by x squared first. So I have limit as x approach infinity, right? X squared over x squared divided by 2x cubed minus x squared divided by x squared, right? I have not changed anything. Now, what do I have left? Limit as x approach infinity, x squared over x squared is 1, divided by 2x cubed over x squared is 2x, minus x squared over x squared is 1. Now, you can put infinity into x here. Then you have 2 times infinity minus 1, which is a very, very large number. 1 divided by a very, very large number is close to 0. Okay, again, so this ends up being 0. So that works. Hope you enjoyed this video. Don't forget to subscribe to my channel. Thank you.